Okay, we're going to do volume squares. And let's see if I can squeeze in rectangles in the same video. Come on. Okay, so you know that volume is the integral of area. And it's in terms of x when a cross-section is perpendicular to the x-axis. Okay, and you know that the area formula for a square is side squared. Okay, because we have a square and we have a side. All sides are congruent, right? So if I wanted to find the side, then, you know, if I have, if it's perpendicular to the x-axis, means we're doing this vertical distance here, and I need that vertical distance. That's my square. That's one side of my square. All right, so this would be defined as, well, then I'm going to do top minus bottom. So S is equal to top minus bottom. And let me label these. So the red one is F and the blue one is G. So that means that S is equal to f of x minus g of x in this scenario. So then my volume is the integral of f of x minus g of x squared, because it's side squared, dx from x1 to x2. Okay, now if I were to change things and this is going to be perpendicular to the y-axis, well then let me erase this here. Okay, so erase that, erase that. So I have this yellow region still, and let's erase that. Okay, so then it's still gonna be the area of y. dy is the integral of area, gives you volume from y1 to y sub 2, and in this case that's going to be the integral of s squared dy y1 to y2, and this is if we're perpendicular to the base of my cell is perpendicular to the y-axis. So perpendicular to the y-axis would be going, let's choose this color, this way, right? Horizontal is perpendicular to the y-axis, so I need this horizontal distance. So you know that we do right minus left, so then S is going to equal right minus left, which in this case is going to be g of y minus f of y. Okay, so my integral is going to be g of y minus f of y squared dy y1 y2, or right minus left squared dy y sub 1, from y sub 1 to y sub 2, whereas the other would have been top minus bottom squared dx. Okay, that's squares.